Clean Coders with Micah Martin.
The Azure and DevOps podcast is a show for developers and DevOps professionals shipping software using the latest in .NET, Azure, AI, and DevOps. Listen on to learn how to increase quality, ship quickly, and operate well. The show is sponsored by ClearMeasure, a full-service software architecture and engineering firm. Find them at www.clearmeasure.com. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. I'm excited about my guest today on the show, Micah Martin. He's a co-founder and CEO and also the studio director for Clean Coders. He's a second-generation programmer. He's a serial entrepreneur, a family man, pilot, airplane builder, engineer, author, and he likes to just be a normal guy trying to enjoy life to the fullest. He's also a co-author of the book Agile Principles, Patterns, and Practices in C#, along with his father, Robert C. Martin, also known as Uncle Bob. And he's a contributor to the popular testing framework FitNesse, among many other things. So, Micah, welcome to the show. How are you, sir?
I'm doing great, Jeffrey. Thanks for having me.
No, my pleasure. My pleasure. There's so many things I want to ask you about, but you've been programming for a long time. For the listeners' benefit, I asked you to kind of go back in time. And are there any high points that were instrumental in getting you into programming and keeping you here?
Oh, man. Well, how far back can we go?
Yeah, your choice.
Well, okay. So, I mean, you mentioned in the intro that Uncle Bob is my father, which is a weird sentence to say.
Right.
But it's an interesting, aspect of my raising because, he was a coder since I was a little boy. And, even back then, he would come home from work, he would code more. Like, he really loved coding. I think he still does. I mean, yeah. In his spare time, you'll find him coding. He just loves it. And it was contagious. So even at a young age, he would show me things on the computer. And I couldn't help but to be interested in what he was doing as well. So, I tell a story a lot where, when I was probably 5 years old or something, he would put me on his shoulders and play this game called Robot, where, I was the boss on his shoulders and I would tell him what to do. Like take me to my bedroom. He's like, oh, command not understood. Like, oh, I need to tell him how to get to my bedroom. It's like, okay, well, start walking. I don't know how to walk. And then I'd have to instruct him how to lift his leg, fall forward, give him all the tiny bits of details to walk. And then he'd start walking. And then we start approaching a wall and stop. I don't understand that. He'd walk right into the wall and bounce off the wall just like a computer would. And it was hysterical. I couldn't help but to love it.
Nice.
So, that had a huge influence on me. And then as I was growing up, he taught me Logo on our Commodore 64, and he taught me to program in C on our first Macintosh, the first Macintosh. And I think the next pivotal moment was when I graduated college, because, I'd spent 4 years at university and I thought I was hot stuff. I was ready to code.
Yeah.
And, I had got several job offers, but my dad gave me a pitch to work with him and I bought it. So my first job was working with my dad. And two amazing things happened at that point. One, I realized that I didn't know what I was doing. 4 years of university, and I did not know how to build software. That was humbling. The second thing was that he was working with all these masters of the industry, like Kent Beck and Ward Cunningham and Ron Jeffries, and these guys were walking around all the time, and it was such an opportunity. I realized the privilege I had at that moment, and I just soaked it in. I learned as much as I could from these guys, and that was very formative for my software career.
Wow. I'll say. Fantastic. And now you run Clean Coders. For the listeners, what is that?
Clean Coders, it's a business. It's really two facets. So the first facet of the business is software training. And let's just get down to it. My dad, around the year 2009 or so, he was interested in making videos. And he was unsatisfied with the options to distribute his videos. And so we talked about it. It's like, Dad, I could write you a website to distribute videos. He's like, oh, it's not a bad idea. Let's start a company to do that. So we started Clean Coders. And for the first 10 years, that's what it was. It was just a website to sell training videos about software.
Mm-hmm.
Around the year 2020, I got back into software. And that's a different story I can tell later, but I hadn't been writing code for several years. Okay. And I got back into software, and the code base for Clean Coders was kind of a mess. And so I got pulled back into it and trying to clean up the mess that was there for the Clean Coders website. And, having not coded for 5 years, I fell in love again. I was like, man, this coding stuff is brilliant. It just, the days go by and I don't know where my time went, and I'm just having so much fun building it. I got to do this again. Mm-hmm. And so I talked to my dad. I was like, we should start up a branch of Clean Coders to do contract software development. And so we started Clean Coders Studio. Same name, Clean Coders brand, but we develop software in our studio for anyone that needs software. So those are the two facets. One is software training, and the other facet is custom software development.
Nice. So on the software training, you mentioned when you got out of university, you realized that you didn't know how to build software. And now I'm sure you've seen so many other young people who've kind of had the same realization. Are there any themes that have emerged that kind of are obvious patterns that just seem to repeat themselves over and over with new generations of developers about just things that they miss and have to learn later in their career?
There's a pattern, and there's one that I've kind of forced, which is a software apprenticeship. If I look back on how I entered software, like coming out of college and working for a software company, it was the fact that I was working with people who knew what they were doing. I was learning from experts, and that was a key difference. And as I talked to other people, like almost everybody who had become a strong developer had a similar experience where there was a mentor in their life who kind of showed them the ropes and got them up to snuff in their skills of writing software. And so early in my days at my father's company, there was this book that went around. It was called Software Craftsmanship by McBreen. So I read that book, just soaked it up. And he compares software to other crafts throughout history, like woodworking or blacksmithing. And the pattern for hundreds of years has been, maybe even thousands of years, has been that people who are interested in a craft will enter that craft as an apprentice, where they are, working with a master craftsman, and their job is to learn the craft. And there are parallels that don't quite work modern day, like indentured servitude, but this idea of learning from an experienced developer, I thought was key. Mm-hmm. And there's another parallel in my stories, which is martial arts, because martial arts was a big part of my life as a teenager and even as an adult. I still, I just got my black belt in Kempo karate.
Oh, wow. Nice.
Doing that with my son. So it's still influential. And in the world of martial arts, you, as a student, you're learning from your sensei, who was a master at this art. And so when I read Software Craftsmanship, that book seemed totally natural. Like, this is how martial arts works as well. Mm-hmm. And I felt like this is how software needs to work. And so I pitched to my dad even back then, in the early 2000s, like, if we're going to hire someone, we should probably hire them as an apprentice, where their job is to learn. That's it, just to learn software, and then after a while, they can start writing code with us. Mm-hmm. And that pattern, I took that to the next company that I started in Chicago. I did that for about 10 years, and apprenticeship was a key differentiator. That was unique to our business. And it was it was great and it was problematic because, our apprentices were, people got to know that, this company that I had was creating apprentices and they were skilled. They knew what they were doing. And so people would start poaching our apprentices, which made it hard because I'll tell you about the program in a little bit, but it meant we were losing money. It was hard for business. But it also meant our teams were very strong. And so when we started Clean Coder Studio, it was a no-brainer. Like, we are going to do apprenticeship at Clean Coder Studio. And so have I seen patterns? Yes, apprenticeship. And I believe that is the way to do it. It works. It's worked for decades for me. And I believe it's the best way to bring new software developers into the industry.
That's a good point of learning from masters. I do remember I had some contracts while I was in college, but I remember after college, the first company that wanted to hire graduates was Dell Computer Corporation. So I kind of went there, and my underlying assumption, my untested underlying assumption, was surely I'm going to go work with the masters. This is Dell Computer Corporation. There's going to be so many people to work from, and there were, but it wasn't universal like I just expected. This untested hypothesis that this famous tech company. So I think that's so important to focus on who am I going to be learning from. I love that.
Yeah,
I love that.
Yeah, I agree.
Now, you teach these apprentices. What are the things that every time you focus on? Like, what do they need to learn? Yeah, they've taken some classes. They probably have a computer science or some related, degree or whatnot, and they've done some things. Mm-hmm. But when they come in as apprentice, what do you see? What do they still need to learn?
Yeah, no, there are some secret aspects to our apprenticeship, some secret sauce, if you will. So trying not to give too many details away. But your typical apprentice will start as they know how to code. And it's part of the interview process. Like, we don't hire people who don't know how to code. So there are programming challenges.
And they probably need to love to code, right?
Yes, they have to have a passion for coding. And so we start them out by teaching them a new language. Like, I love Clojure. Clojure is a great language. We use a lot of Clojure. So, let's start out by having them write some Clojure code. For anyone who knows how to write code, learning a new language should not be a terrible challenge. Right? It's just, it's the same thing with different flavors, right? Coding is the same no matter what language you're using. So we start them just warming up by learning a new language, just doing some fun exercises, maybe some Project Euler problems, or we also use the Koans, which is an interesting way to learn a new language. And then we start to build software. Lasting software. What you'll find with a lot of people that get out of college is that they know how to solve problems, right? They've built data structures, they've written algorithms because those are the classes they had in college,
right?
And getting those programs to work is one thing, but then to live with that software, to extend it, to maintain it, is a whole different story that most people at an entry level have never experienced. Like, how do I live with this code that I've written? And so we work on these projects that they have to live with their code week after week, and they have to extend it and modify it. And those are important skills to develop. Another aspect of our apprenticeship is the Agile process. And I know you talked with my father about this a bit. Like, we prescribe to the extreme programming model pretty much. Pretty closely. So we use test-driven development, 1 week iterations. They write stories, they estimate them. The customer prioritizes the stories. Getting new developers used to this style where they have to deliver every week, like they don't have a whole semester to build their project. No, we need results in a week so that we can ship it. That's an important lesson to learn. And then also this idea of when you estimate a story and it gets prioritized in an iteration, that is a commitment. Like, you've told us how long it's going to take to build, and we've given you that much time to build it. If you don't deliver at the end of the week, then you are not fulfilling your commitments. This seems to be a big issue as well for new developers. Like, oh, I actually have to deliver this? There's a deadline. So that's how things get started, and then we just build on it from there to prepare them to work with the rest of our craftsmen on client projects.
Nice. Yeah, there's so many conversations around Agile that have happened in the last 25 years, and that commitment has seemed to be a very important aspect from where I sit. Now, extreme programming and test-driven development, those have been around a long time. I know this is an older framework, but you put a lot of work into the FitNesse testing framework. And I bring it up because it doesn't seem like that problem set is still universally fixed in the industry. And so I want to pick your brain, like how you think about that problem set. I know FitNesse is old. Is there anything that's kind of replaced it, or technique, or can you talk about the importance of that type of testing?
Yeah, so FitNesse is a acceptance testing and standalone wiki all in one project. And just for the background, like Ward Cunningham invented this framework called FIT, a framework for integration testing. Acceptance testing is one of the practices of extreme programming. These are high-level tests written by the customer to make sure that the software does what they wanted you to build. And we were using FIT in our training classes at my father's company, and we needed a way to make it easier for customers to write these tests. And we can't expect customers to be checking code out of source control and editing text files. They just don't have the patience for that, we found. So what we built is a wiki, another one of Ward Cunningham's inventions. So we just took two of Ward's creations and smashed them together into one project. And as a wiki, now this is a website, and customers can go into the website, look at the test that they're interested in, hit the edit button, and just edit the test in the wiki. And then the developers can take that and run that against their code. So that's what FitNesse is. And there's lots of tools and techniques built into FitNesse to allow you to organize and manage your tests. Acceptance testing is a critical component of software development. And I will say that on the start of projects, we don't typically do acceptance testing because we have this very tight-knit communication where we can get away without doing it. But once you reach a certain maturity, that need arises. You need something to help you scale. And acceptance testing is the tool of choice. So yes, I still use acceptance testing. Like these days, Cucumber seems to be one of the main tools, and we use Cucumber a lot for our acceptance testing. But I long for the ease of use that FitNesse gave us. Now FitNesse, I won't use FitNesse again. I mean, I do every once in a while. I spin it up and I start running it.
Yeah, it's older.
But the techniques we used are kind of antiquated. And so I've thought many times about building a more modern version of FitNesse because the need for that type of shared resource that FitNesse gave, the developers and the customers were using the same tool, and there has been no replacement for it, and we need one. Right. So I think if someone doesn't build it, I think my team might build it. Yeah, we'll see.
Well, that's true. You mentioned Cucumber and Selenium and Watton. If you think of the Playwright framework, those are all basically web browser drivers. Open it up, go to a page, click on something, and that's yet more programming. And what I remember about FitNesse and just that technique was the non-programmers were actually able to write what in effect was the script because it was so natural language. Just these tables. And I was talking to another podcast guest, and this is just a hypothesis, but they were opining of whether a series of AI prompts could be the natural language bridge to the script that was necessary to, run a browser, click on a button. But that's just hypothesis at this level. You're right. There's a gap. There's a gap there in our industry, isn't there?
Yeah, there is. And this is one of the things I think AI excels at is generating test data. Maybe not so much tests because writing tests is a lot like coding. And again, AIs start daydreaming and go off the rails. So they still need to be supervised. But they're a great tool for generating tests. And now you got me thinking. I'm going to have to mull over that some more.
Well, you do a lot of teaching, and I do less teaching, but some amount. And what I've found myself explaining to people is, in order for developers to write the proper code, they need to know all the supported scenarios. And trying not to use any jargon, what I end up telling them is jot down some bulleted test scenarios. Once they say, "Hey, I'm done with this," you already know what things that you're going to check to make sure that, hey, it does what you want it to. Can you just jot down some bullet list of, if it's a stupid login screen, a simple login screen, you're probably going to check, good username, good password. If you wanted to show, wrong okay, what message did you want? Where do you want it to show up? And if you're doing a wrong password, you already know those scenarios. Can we jot them down maybe ahead of when the developer writes the code? And then, well, guess what? The developer can easily just take those scenarios and make them into executable tests, and boom, now you have acceptance tests.
Make them execute, yeah. And then you don't have to do it manually. Right? Just let the computer run through those tests for you. Then makes your job so much easier.
Yeah, let the people, I don't know, make up some tests on the fly, do exploratory testing, as opposed to, let me check the baseline conditions. So now I want to ask you about, this is often brought up, the notion of craftsman versus engineering as if dichotomy. And no analogy fits perfectly. But how do you think about those two concepts, or do you even care?
No, I do care. Yeah, I care a lot. In the podcast you did with my father recently, you guys talked about what happened to Agile, and he talked about how it got taken over by the Scrum Masters.
Yeah,
the managers. And I watched this happen because we were in my dad's father. We were organizing those conferences at the beginning, like XP Universe, and Agile Universe, and those conferences were glorious. You get a couple of hundred developers all together. And man, it was great. Like, I remember meeting some of the most amazing people, and we would have these sessions where we would just write code, like Hunt the Wumpus games, but our focus was on test-driven development. So people would just sit down and you'd start writing TDD with strangers that you never met. And we were just totally geeking out. Those conferences were wonderful. But over the years, it's exactly as my father described. Like, it started being taken over by the managers, and it wasn't about coding anymore. It was more about the process and the management of the developers, to the point where I stopped going. And it was really sad. And at the same time, I was doing consulting work for my father, where we'd go into companies and help them transition to an agile process. And we found that lots of these companies had adopted Scrum because that they had hired a Scrum Master, and so
there was certification.
Yeah, they were certified, and so they'd start doing Scrum, which the Scrum Masters would have them do all of the high level parts of the process, like working in sprints and writing stories. But they were missing all of the developer practices, like writing tests and refactoring and pair programming and all this stuff. And so they don't work separate, right? You can't just do the high level part of Agile without doing the developer disciplines as well. So a lot of my job was just helping these companies with their developer disciplines. And we wanted to fix this problem that had happened in Agile, where it turned into this management process and not a developer set of disciplines anymore. And so going back to this book I read with Pete McBreen, like Software Craftsmanship, like this is a craft, and we need to get back to the craft of software, and the skills that the developers have, and so building. I basically copied what the Agile Manifesto did, right? I thought this software craftsmanship thing was a big deal, and so I would talk about it a lot, and we got a group of people together after momentum had been built, and we had a software craftsmanship summit at our office in Libertyville, Illinois. And we wrote down some principles which look a lot like the Agile Principles. And then we created a website to publish our Software Craftsmanship Manifesto, and we would have people sign it, just like the Agile Manifesto. Because it is, in my mind, it was the same thing. And so we should use the same process to bring this to the industry. And so I think software craftsmanship is more, it's part of Agile. It's the part that got forgotten, and we can't forget it, right? Developer disciplines are, I think, maybe the most important part of the Agile processes.
Yeah. A few months back, I had a conversation with Jeff Sutherland, who, he's a long timer and was one of the original originators of Scrum, and he was kind of talking about the same thing. It's that before Scrum kind of came into software, his time in the Navy, he talked about the 1970s and 80s when it was just kind of in its infancy. It was very much about technical aspects. and he talked about the transition to project management. And he said a term that I hadn't heard before, which is, he said, what I'm focused on now is extreme agile. We need to go, as an industry, 30 times faster than what is average in our industry right now. And of course, he had an AI focus and whatnot. But the fact that, one of the co-creators of Scrum kind of agrees with this sentiment. We need these technical practices in here, and it's missing.
Yeah, I think they're key. And so, like, if we try to wrap everything up in a bow here about like what I do is I'm Uncle Bob. He's my father. Kind of like my sensei, right? I'm a student of clean code, the clean code style of development. It's a system of software development that works. It's proven. Just like, martial arts, karate. It's been around for a long time. It's proven, and that's what makes it a lasting discipline. So, we practice the clean code discipline of software development. And in the Clean Coders video side, we sell the videos to teach people the clean code side, the clean code discipline of software development. And on the Clean Coders Studio side, we put it into action. We practice what we preach. Like, we practice clean code systems, disciplines of development for our clients. And so I'm just I'm just carrying forward the torch of clean code. I think that's a lot what I'm doing these days.
Yeah. It seems like what everybody wants code that works, that doesn't have bugs, doesn't have surprises. And it seems like clean code is a way to get that. Now, I've read the clean code book that your father wrote. Is there just to point the listeners in the right direction, is there a checklist, a standard for what clean code means that the listeners could pull down?
Well, that is a great question. I mean, there is...
Maybe we point them to the book, because there's a whole book on it.
There definitely are the books. There are also 60-some episodes of clean code videos on cleancoders.com. And we're currently working on the next phase of what cleancoders.com will be, where we're trying to digitalize this apprenticeship experience. Right now, it's like a one-on-one relationship between the apprentice and the mentor, with the goal of becoming a craftsman at Clean Coders Studio. But there is a desire from a lot of people to go through this apprenticeship experience without necessarily tying it to a career at Clean Coders, right? They just want the skills under their belt. And so we're working on a program to put people through an apprentice-like experience on the cleancoders.com website with the help of our craftsmen. So, like, they will have a mentor. It won't be the one-on-one personal interaction, at least not all the time, but it will help people to kind of go through the whole gamut of clean code apprenticeship.
Nice. I think one final theme as we kind of head to the end of the interview. You've been programming for a long time now, and of course everybody's asking this question. How are you putting AI in your programmer's tool belt? What does that look like, and how do you think about it? What are you doing?
Yeah, well, we've had clients that have asked us to take deep dives into AI. I will say, on the surface, like, I use AI. I'd be a fool not to. It's a great tool to help you. For example, if I have an algorithm to write, I'll ask AI, just write me the algorithm. Let me look at it. Yeah. And then, I might ask them to write different versions of it just to get a feel for it. And will I copy that code and put it into my code base? I feel more comfortable writing it myself. Like, I might just look at what he did and then write a little bit of code, look at what the AI did and write a little bit more code. But I want to feel like I understand it. Like, I own that code now. So I won't just copy it into my code base, but I'll use it a lot. And like I said earlier, it's great for generating test data. You give it the shape of data you need and ask it to generate it. It'll just generate it infinitely. Like, it's wonderful.
Yeah.
Some of the work we've done for clients is, they were really interested in translating existing code bases. So we did a deep dive using Claude and ChatGPT and Grok, comparing how they would take one code base and translate it into another code base. And on the surface, it would work somewhat well. I think Claude was the dominant AI in this case, but it wasn't automatic. Like you still had to hold its hand and convince it to do it the way you wanted it. We had tests for our code, so we needed to translate the tests as well. But in every scenario we put it through, it would go off the rails at some point and just start daydreaming. It's not there yet.
Yeah.
But it is a tool we need to use. And someone once told me that AI is not going to replace us as developers, but the developers who best know how to use AI are going to put the ones who don't use AI out of a job.
Mm-hmm. It seems like we're going faster. I still remember searching for, okay, what is the right syntax to get something happening? I still remember searching Usenet groups, and then it was Google Groups or Deja News, and then it moved into Stack Overflow and all. It's just, I'm searching for syntax. And I spent a lot of time just saying, it's like, what is the right way to get it to do this? And now all of that time is basically non-existent because just the searching capabilities are instantaneous. It's like, I don't have to remember syntax and I can get it just like that. That's a huge time save, right? Just that alone.
Yeah, it's amazing. I remember back in the days before Google, I used to keep a stack of books on my desk so I could look up the syntax.
Right.
And then Google made it way easier. You'd find a Stack Overflow page that had the syntax. But now you just ask AI, hey, Grok, write me this code. It does it.
Yeah. It seems like a lot of futurists are wanting this, this new computer tech to just completely write the whole system. Whereas it's like, wait a minute, hold on. We're just getting to the point where I can maybe reliably generate a method. We've still got a long ways to go before we can talk about, larger pieces of software. But it does seem to be like a progression. It's like, well, it's generating this much code and, well, golly, that's pretty darn close to how I would have done it. And then it's like, okay, when is it going to generate this much and then this much and then maybe multiple classes? I don't know.
So do you think it'll get there? Do you think it's going to replace you?
Replace me? No. I mean, my opinion is that as long as we are putting our programming language in the version control system, we are going to have to be experts in that programming language. But at such time where maybe there's a different language that's actually being put in a version control system, well, then, okay, well, now we have a whole nother generation of languages. And okay, are there more people who can speak that language? Like, we're not putting prompts into Git right now. I think that if that were to happen, where there was some system where you could just put a series of prompts and then poof, out the other end, after some automation comes a software system, that would change things. But right now, we're still putting computer code in those systems.
Yeah, I don't think it's going to replace us either. I do think that we still need humans to specify all of the details and the branches in the code. And we even explored the idea of if we have a suite of tests for what the code should do, maybe we can have the AI generate it. But I had some conversations with my dad about that, and then exploring it further, there's this aspect of when you're practicing TDD, right? You've got this dual entry bookkeeping approach where you're writing the code twice. You're writing it once in test form and once in production form, and those two pieces together mirror each other and stabilize each other. And you carry that forward, and it stabilizes your whole project so that you're not actually introducing bugs or breaking it somehow.
Right.
And if you can give AI a set of code where you've got the tests and the production code to stabilize each other, then AI should be able to understand that. And it doesn't matter what language you built it in, right? The AI can just translate it into another language. And, that's very powerful. And maybe it can even start modifying it. But that's where it breaks. In that part of the exercise, you still need humans to hold its hand.
We see the progression. It's anybody's guess at how far it will be able to go. We definitely see the progression of it saving me time in writing the code. But just like self-driving cars, it becomes not a technical problem, but a human problem of, okay, let's say that a computer was completely able to operate that car. Mm-hmm. Do we want it to? And I think it's like, whoa. Before we start talking about cars, why don't we have completely autonomous trains? Or we have trams, we have little shuttles, but I'm talking about freight trains. It's on a track. There's a reason why we still need a person to be responsible for the operation of the machine. Who cares how automated or how fancy this machine is? The question is, does the machine still need to be operated? Mm-hmm. And that's more like a human judgment thing. And I think the same thing in development. I want the tools to be really awesome and save tons of time and be able to save a whole lot of work. But but even if all the code for a particular feature was able to be perfect, it's like, okay, well, somebody still has to, operate it, be the glue, think about, should it be like this or should it be different? Like in the building world, the analogy maybe is partial, but I've seen these 3D printer, concrete houses starting to being built where you squirt concrete and you make the shape of a house instead of, cinder blocks in that case. But that's a long way from saying, I don't need a civil architect.
Right.
It's like, the construction crews may save a lot of time and the house may get built a lot faster, but okay, that's a chunk of work. That means, hey, we got more efficient, but the job didn't go away. The job just got more efficient.
Yep. And, another industry, you mentioned I was a pilot in the intro, is aviation, right? We have got autopilots on planes that do amazing things. Like they can fly the plane. A new feature of general aviation planes, Cirrus planes, is that there's a button you can push. Like if something happens to your pilot, you push the button and it will find the nearest airport and land itself. The plane will do this all by itself. It's just so good. However, you still need, in that event, you don't have a pilot. But in most cases, when you're using the autopilot, you still need a human there to monitor, because there are situations like icing. Like if you start to pick up ice on your wings in the airplane, the autopilot can't look at the wings and know that there's ice on the wings. Yeah, and right. It'll start to compensate for the effects of the ice on the airplane to the point where it'll stall out, and there's been accidents where the autopilot just crashes the airplane because it doesn't know what to do. And so you still need the humans there to monitor it and babysit it. And just like in software, we need humans there to monitor and babysit.
And these are machines. Every machine has to be maintained. Every machine is going to break down at some form or fashion. You could have autonomous car races at some point, but you're probably going to have a race team that they're better operators of this automated race car if that actually happens. So well, this has been a really, really intriguing conversation. I appreciate you sharing your career and Clean Coders and how you think about that. And I think hopefully we intrigued some younger developers to think about who they have hitched their wagon to. Who is their sensei? Who is their master?
Yeah, but mentors are great. We should all find one. Right,
exactly. But well, thanks for coming on the show and visiting with me today.
Thanks,
I really appreciate it. Yeah, my pleasure. My pleasure. Well, until next time, dear listener, keep shipping.
You've been listening to the Azure and DevOps podcast. You can find us on YouTube, Apple Podcasts, Google Play, and anywhere you get your podcasts. Visit our sponsor, ClearMeasure, at www.clearmeasure.com. And on behalf of your host, Jeffrey Palermo, thanks for listening, and may God bless you.